In this video, we're going to discuss the naive method for finding a modular inverse. Consider the expression AX is congruent to B mod M. A non-zero integer A has an inverse if and only if A and M are relatively prime. The modular inverse can take on values 0 through m minus 1. Using the naive method, we're going to find the modular inverse when a is equal to 5 and m is equal to 11. In other words, for ax congruent to B mod M, we wish to find the value of x, our modular inverse. Setting up the problem, we have 5x is congruent to B mod M, where M is 11. Since we have mod 11, we know that our inverse can take on one of the values from 0 to 10. In addition, we know that an inverse exists since 5 and 11 are relatively prime. So let's get started. Let's start by testing the value 0. 5 times 0 is congruent to 5 mod 11. Since 11 divides into 5 0 times with a remainder of 5. Next, 5 times 1 is congruent. I'm sorry, let me back this up here. 5 times 0 equals 0. So 5 times 0 is congruent to 0 mod 11, since 11 divides into 5 0 times, and there is a 0 remainder. 5 times 1 is congruent to 5 mod 11. This is because 11 divides into 5 0 times with a remainder of 5. 5 times 2 is congruent to 10 mod 11, since 11 divides into 5 0 times with a remainder of 10. 5 times 3 is congruent to 4 mod 11. And this is because 11 divides into 15, our product of 5 times 3, one time with a remainder of 4. Five times 4 is congruent to 9 mod 11. Since 11 divides into 20 one time with a remainder of 9. Next, we have 5 times 5. This is congruent to 3 mod 11. Then we have 5 times 6. This is congruent to 8 mod 11. Five times 7 is congruent to 2 mod 11. Five times 8 is congruent to 7 mod 11. Five times 9 is congruent to 1 mod 11. And here we have found our inverse. Let's plug in our final test value. 5 times 10 is congruent to 6 mod 11. So we know that 9 is our inverse, since 5 times 9 mod 11 is equivalent to 1. In other words, we divide 11 into 45 4 times, and our remainder is 1. Notice that as we progressed through the naive method for finding a modular inverse, each of our remainders from 0 to 10 occurred only once. We had 0, 5, 10, 4, 9, 3, 8, 2, 7, 1, and 6. This represents all values from 0 to 10. However, there's only one inverse, and as we found, our modular inverse is equal to 9. This concludes our example. I hope you found it helpful, and we'll see you next time.